Problem number 12. Determine where this function is continuous, piecewise defined. So there's definitions for x is less than 3, x is equal to 3, x is between 3 and 4, x is bigger than x is equal to 4, x is strictly larger than 4. At x is bigger than 4, this is a polynomial. X is between 3 and 4, this is a polynomial. So x is continuous for 4 on the interval from 4 to infinity. It's continuous on the interval from 3 to 4. And it's for this one, this is a rational function. These are continuous as long as they're defined. They're defined if x is not equal to 3. So this is going to be continuous on the interval from negative infinity to 3. So it's continuous everywhere except potentially at 3 and 4. I say potentially. We have to do calculations to determine whether or not it's continuous at 3 and at 4. Okay, at 3, what do we need to do to see that this is continuous? Limit x goes to 3 from the left of f of x needs to equal the limit x goes to 3 from the right of f of x, and that needs to equal f of 3 itself, which is 0. Okay, so what do we get here? X is coming to 3 from the left. We are less than 3 here. Limit x goes to 3 from the left of x squared minus 9 over x minus 3. So when we plug in 3 into this, we'll get 0 over 0. So we think about factoring. The numerator factors as x minus 3 times x plus 3. And so those cancel. And we're just left with a limit x goes to 3 from the left of x plus 3. Evaluate by substitution, and we get 6 here. And in fact, we can just stop here. The limit from the left does not equal f of 3. And so this is not going to be continuous at 3. If you do calculate out the limit as x goes to 3 from the right of f of x, let's say the limit x goes to 3 from the right of 5x minus 9, this is equal to 6, and so the limit here, the limit as x goes to 3 of f of x does exist, but it doesn't equal f of 3, which is 0. Function is not continuous at x is equal to 3. Okay, now we have to do the same thing for x is equal to 4. Limit x goes to 4 of f of x. Limit x goes to 4 of 5x minus 9. And this one is going to be plug in 4 here. 5 times 4 is 20 minus 9 is 11. We want this to equal f of 4, which is 11, so that's a good sign. We still need to calculate the limit as x goes to 4 from the right of f of x. The limit as x goes to 4 from the right of 27 minus x squared. Again, evaluate this by substituting. 27 minus 4 squared is, in fact, 27 minus 16 is 11. All of these equal. So this is continuous at x is equal to 4. So the only place that our function is not continuous as x is equal to 3, so it's continuous on the interval from negative infinity to 3, union 3 to infinity.